Let's briefly go over this. Law of cosines is a different law you can use for oblique triangles. Law of sines. What were the three cases when we used law of sines? LOS. Law of sines. What were my three cases when I could use law of sines? Remember this.
When you
Angle, angle, side. Nope.
Angle, side.
Angle, side, side, or side, side, angle.
Yeah.
Dyslexic. All right. What else?
Side.
There's one more other case.
Side. Angle, side.
Angle, side, angle. So that doesn't disappear. If you're given three parts of a triangle and it fits those three criteria, you still use law of sines to follow that process out. Now we're going to add a new process or a different way. If you're given an oblique triangle and they give you three sides, or they give you two sides in the included, which means between, okay, or between the angle in between those two sides, so that'd be side, angle, side, okay. If I'm given that, then you can use law of cosines. It's always best, not saying it has to be, but it's always best to start with the smallest angle first, okay? So when you're going through law of cosines, if possible, if you're trying to find side lengths or trying to find angle measures, start with finding the smallest possible angle or side first, all right? So here we have our three laws, okay? Now, it's pretty easy to go from one to the other. If I look at this, right? This right now is solved for a squared. So how would I get from here to there or there to here? Just got to take a little bit of arithmetic, right? Take a little bit of algebra, but all I have to do is either subtract the a squared over and add the 2bc times the cosine of a on the other side, and then divide by 2bc, and that gets that back over here. Okay? Or if I'm solving for a squared, I multiply this by 2bc, then I subtract b squared and c squared, but then I multiply by a negative, and it flips all the signs. So for the most part, if you can remember one of the two formulas, you can algebraically get back to the other one. Okay? Now, if I'm look at this. If I'm solving for big B, this is how I always remember it, right? If I'm solving for big B, opposite of big B is little b. And little b only shows up once on the other side. Every other time, it's A and C, the two sides adjacent to angle B. So I'm adding and subtracting the little side I'm trying to find, and I'm multiplying by the two other little sides that I know. Okay? So let's see if we can kind of work our way through this. Solve the triangle given little a is 6, little b is 10, and the included angle is C, and he's 80 degrees. So I'm going to draw a picture here where angle C is 80 degrees, and it's included between the two sides, 6 and 10. Labeling the three vertices and labeling the sides I know. So by looking at the picture, I know it's side, angle, side because I have an included angle between two given sides. So I'm going to have to use, okay, law of cosines to find some missing information. If I know two sides, I'm most likely going to find the third side, little c, by using my law of cosines. I want to find c, so I'm going to have to find c squared first. So c squared is equal to a squared plus b squared minus 2 times ab times the cosine of c. A I know is 6. B I know is 10. And I know the angle of C is 80 degrees. Since that angle is 80 degrees, we're not finding the small side first, but there's not much else we can solve for first here. We're just going to have to go with it. Alright? I can't use law of sines because I don't have a pair of opposite angles and sides that are congruent to each other, so I need to use what I have. This is a calculated problem at this point, so I'm going to have to do 6 squared plus 10 squared minus, in parentheses, 2 times 6 times 10 times the cosine of 80. Hopefully I'm in degree mode. And end up with 115. Yep, I'm in degree mode. 115.162. Now, the problem with that is, that's really, really big. What did I forget to do? Yeah, since I solved for c squared, I have to go back and also square root this value. Which is really easy with these graphing calculators because I don't want to round to the very end. So I'm going to take this long decimal, and I'm going to hit second x squared, and I can hit second negative sign to put in that answer under the square root. 10.731. Now, that's only the small side of C. So angle A, angle B, angle C, side A, side B, and side C. What am I still missing here? Missing a bunch of angles. So, now I have all three sides and I have one angle, but I still need two more angles. At this point, you really have two options. You can follow with the law of cosines, and we're going to practice that today since it's a new formula. Or, now that you have a pair of a side and the angle opposite of it, you can jump to law of sines and go from there. Okay? So, once I have a pairing of a side and its opposite angle, then I have enough to use law of sines. However, I'm using an approximated value, so I have to be really careful with my rounding. But let's just go ahead and keep going with law of cosines, and we'll see where that takes us. So, what angle am I going to find next? Well, let's go ahead and just find angle A, for example, right? Angle A. In the two law of cosines, angle A is kind of isolated over here, so I'm going to use that first formula on the right. Cosine of angle A. Now, what's adjacent? Look at this real quick. What's adjacent to angle A? C and B. So I'm going to do C squared plus B squared minus the side opposite, which is A squared, all over 2 times, what are the two sides adjacent? C and B, or B and C. Okay? So, once I have the formula down, I'm going to go fill in the spots that I know. And I'm going to take the cosine inverse, because A is really going to be equal to the cosine inverse of this value. C squared I already know is 115.162 ... plus B squared, that's 100, plus minus A squared, which is 36, all divided by 2 times B, 10 times C, which is 10.731, ... Gotta be really careful about how I put this in my calculator because I don't want to screw up my decimals. So, nice thing about a calculator is I have this whole fun fraction kind of thing I can get going on here. I want to do the second cosine inverse of alpha y equals 1, kind of gives me a fraction. In the numerator, I want to use this 15. See up here I have the 15 in there already? Or I can go up to 10. I can go highlight that value. I'm going to take that number plus 100. That's 1,000. Minus 36. All divided by 2 times 10. That's just 20. Times this value. Oh, darn it. That didn't work out the way I planned. That's alright. It is my most recent answer, so maybe I can just do second answer. And let's close the parentheses, see what we get here. 33.409. How's that sound? 33.409.
Where's the second answer?
A lot of calculator steps right there. But if I can put it all together at one time and make sure all my parentheses, everything's lined up correctly, then I don't have to worry about maybe mistyping something in the individual steps. Okay? Now, once I find the angle of A, angle of B, don't make it hard for yourself, right? To find the last angle, angle B, all I need to do is the measure of angle B is going to be equal to 180 degrees minus the sum of angle A plus angle C. So, angle A is in my calculator. It's pretty fresh. It's 33.409. So I'm going to do 180 minus angle A, which I have right here, plus angle C, which I know is 80 degrees. Close parentheses, so I take their sum and subtract it from 180, and I get 66.591. You solve the triangle using law of cosines. Once you feel up for it, go ahead and jump to the next page and see if you can try this one. Where we just had an example of side angle side, here we now have an example of side side side, which you can also do with law of cosines. You just have to first find a angle. So, always draw a picture to get started. And you label your angles too. Got to pick an angle to go through first. Just got to go alphabetical here. Yeah. Well, actually, what did the top say? Always try to go with the smallest one first, right? So, out of the three sides, A is the smallest side, so it's going to be opposite of the smallest angle. So I usually want to start with going with the smallest angle first. Okay? So, I'm going to use the cosine of an angle, A. And from memory here, we're going to try to remember our formula. When I have the cosine, I have a fraction here. The bottom has a 2 in it. The top's got two pluses and a plus and a minus. So, the first thing is, what are the two sides adjacent to angle A? Little b and little c. So I'm going to do b squared plus c squared, and I'm going to subtract from that a squared. On the bottom, the two sides I added, I'm going to put them in there, multiply the 2. So A is going to be equal to the cosine inverse of b squared is 17 squared plus c squared is 22 squared minus 13 squared all over 2 times b times c. So I can put that whole thing in my calculator. Just make sure I'm careful with my fraction. So I'm going to do the cosine inverse, fraction, 17 squared plus 22 squared minus 13 squared, all divided by 2 times 17. 36.149. So I found angle A, and now I have an option. I can go law of sines and use the A in angle A, or I can keep going with law of cosines. The nice thing about my calculator here is that I've already kind of put in all these numbers. I just got to switch a couple of them around. Look out when I solve for the next smallest angle, B. I'm going to do cosine inverse of, but all I'm going to do is I'm going to switch A and B in my equation above. Now this is going to be 13 squared plus 22 squared minus 17 squared. Everybody see I just switched the 13 and the 17? 2 times 13 times 22. So if I just go back to my calculator and I just switch, I hit second answer, I can quickly just switch a couple numbers and I don't have to retype that whole thing. So I just go up here, turn this 17 into a 13. Turn this 13 into a 17. And turn this 17 into a 13. It's cheating, Mr. Ausel. You're a cheater. $50.479. Once I have two angles, how do I find the third? Add them, take away from 180. So, I have big long decimals on my calculator, so I'm going to use that to my advantage. So I'm going to take 180 minus the sum of the two other angles, which are right here in my calculator. So I can just go ahead and go up to that one and add to that one. Close parenthesis, and I get 93.372. And that's using law of cosines. Here's our bearing problem from our homework. Not as challenging. For some reason, it's a little easier. So a ship travels 50 miles due east. So maybe it would have been helpful if, like, they said the plane was taking off due north and it turned 40 degrees, but whatever. Here, I'm traveling due east. So if I'm 50 miles due east, north, south, east, west, I don't know. For me, it was never eat soggy Wheaties. But some people out there are a little thing. Whatever. I'm heading due east, so again, my ship is traveling this direction 50 miles. After I travel 50 miles, then it shifts a course that is north 75 east, so northeast 75 degrees. However, it's all based off of, the bearing is all based off the initial position. So the initial value is north first, and I'm going northeast, so going from north to east. That's the 75 degrees that I'm going to add to that value. So, once I add 75 degrees to that, then I travel another 125 miles, and then I end at my stopping point. Here's the triangle that I create between my starting position and my finishing position. It's a very oblique triangle. It kind of looks like this. The question is, what's this angle right here? Because those are where all my directions change. It's definitely obtuse, so it's more than 90. This is 75. What's this angle right here? If I'm going from east and then I go north, it's going to be a 90-degree angle. So I'm going to go ahead and add 90 to 75 to give me 165. So that's my measure right there at that angle. I know this is 50 and this is 125. So once I know the two sides adjacent and the included angle between those two sides, this is an example of side angle side. So if I'm trying to find the actual distance between the starting point and the ending point, I'm going to use law of cosines to find that value right here. So, law of cosines says that x squared is going to be equal to 50 squared plus 125 squared minus 2 times 50 times 125 times the cosine of 165 degrees. Again, that's just coming from the formula sheet for right now, but eventually you're going to get to a point where you can kind of have that tucked away in the memory. Cosine of 165. It's a big one. Oh, it's negative. Interesting. But it's going to be negative, so negative is negative. Alright, so in my calculator, 50 squared plus 125 squared minus 2 times 50 times 125 times the cosine of 165 gives me a value of x squared being 30,199.07283. But I don't want x squared, I want x, so I'm just going to square root that value. Square root, second answer, or second minus, second negative, and I get a value of 173.779. What are my units going to be? Miles. Miles Davis. One more problem. Not bad, guys. Not bad. Alright. So, triangle garden here. Similar type problems we did last time. Last time we were trying to find the area of that triangle garden. Here we're doing the actual angle measures of that triangle garden. Okay? But the only thing we know is we know the perimeter, we know the side lengths we want the triangle to be. We want it to be an 18 by 20 and then by 30 triangle. So those are my sides of my triangle. I can label A, B, and C kind of arbitrary values. Doesn't really matter what I pick. I'm starting with angle A being on the shortest side of my triangle, because when possible, I always want to start with the smallest angle first. So if I pick angle A to be opposite of 18, I want to start with that angle in finding my measurements. So angle A, cosine inverse of the two sides adjacent, 30 squared plus 20 squared minus 18 squared, 2 times 30 times 20. I'm just pulling that out of the formula. First angle, 35.577 degrees. So most likely when you measure it out with your protractor in your garden there, 35.5 degrees, roughly around there, that'll work. Protractor, right? Alright, and then I want to start with the next smallest angle, so that'd be angle B. Cosine inverse. And again, all I have to do is switch a couple numbers here. Because if I'm standing at angle B, I want to use 18 and 30 and find their sum. So I'm going to switch the 20 and the 18. If you can find a pattern in the formula, it kind of helps you kind of quickly put that into memory. You got to find a pattern though. This is going to be a 18. That's going to be a 20. This is going to be an 18. And that's going to be 40.274. find the third angle. Just going to have to add them up. Take them away from 180. What did I do wrong? Did I do something wrong? Alright, alright.
Mr. Ausel?
Yeah.
So I did the cosine triangle formula for all three of them.
Yeah.
And when I added up the angles, it only came out to be 175.23. Is that just because each of the angles is an approximation?
Yes.
Okay.
Yeah.
Well, aren't we supposed to only so when we're actually adding the two, do we add the approximations or the actual?
What's to do